Graphicara Hill University, Dehradun School of Pharmacy, presents this session for pharmaceutical organic chemistry. And today we will learn about the alcohol. In the previous classes, we have done the alkyl halides. Now, in continuation to that chapter, we will learn about the alcohols. I'm Associate Professor Dr. Ahmed Nawaz Khan from School of Pharmacy. So, in the previous class, from part 1 to 6, we have done the classification of alkyl halide. What are the preparation reaction for the alkyl halides? What are the reaction which are chemical reaction of alkyl halide and the physical properties of alkyl halide? And then we understand that what are substitution nucleophilic 1 and substitution nucleophilic 2 reaction with mechanism. And then we have seen that what are several examples of the alkyl halides. Now, in continuation to that chapter, we are moving towards the alcohol. Alcohol are the organic compound in which one or more hydrogen atoms from the hydrocarbon have been replaced by hydroxyl group, like methanol, which is derived from methane. When the one hydrogen from the methane, CH4, is replaced by hydroxyl group that makes CH3OH, it becomes the methanol. The general formula for a simple acyclic alcohol. These are the acyclic example, methanol, ethanol. These are cyclic alcohols, cyclopropanol, cyclohexanol. So the general formula for simple acyclic alcohol is CnH2n plus 1OH, where n is the number of the carbon, it may be 1, 2, 3 and so on. These alcohols can be viewed as organic analogues of water in which one hydrogen atom is replaced by an alkyl group R, which is represented by R. These alcohols, they are most common and useful compound in nature, widely used in industries, and they all are around us. The simplest and most common example of the alcohol is methanol and ethanol. In some alcohols, the OH group is attached to a sp3 hybridized carbon, which is next to the carbon-carbon double bond, and that is to an allylic carbon. This is sp3 hybridized next to the carbon-carbon double bond, and they are known as the allylic alcohols. In some alcohols, the OH group bonded to a carbon-carbon double bond, that is a vinylic. This is known as vinylic, directly attached to a carbon-carbon double bond, or to an aryl group like this, which is the phenol, which has itself its own chemistry, phenol, double bond. There are some aromatic alcohols too, but we are not here to discuss them. But I'm just giving you an example. Like this is a phenol. The OH is directly attached to the benzene ring. While the aromatic alcohols, there is a carbon. The OH is attached to the benzylic carbon, which will be over here. If the OH hydroxyl group is attached to that carbon, that will be the aromatic alcohol, like benzyl alcohol. Now, classification of the alcohol. The same way as alkyl halide are classified, these alcohols are also classified into monohydric alcohols, dihydric alcohols, and trihydric alcohols. So, just like alcohol are classified into following types on the basis of number of OH group which present in the molecule and the nature of carbon attached with OH group as follows. Like there is a one OH which is attached to a carbon. So this is known as monohydric. If there are two hydroxyl group attached to adjacent carbon, this is known as the dihydric alcohol. Trihydric alcohol, they contain three OH groups like 1, 2 and 3. Now there is one more classification which are primary, secondary and tertiary. So with primary, secondary and tertiary, these are, we know that what is a primary carbon? A carbon which is attached, the carbon which is attached to a carbon is known as the primary carbon. When the carbon on which the functional group is present. Now this functional group is present to this carbon, and this carbon is surrounded by 1 and 2 carbon, that means it is secondary carbon. Here the tertiary carbon is because the OH hydroxyl group or the functional group attached to this carbon, and this carbon is surrounded by 1, 2 and 3 carbon, that means it is tertiary. So respectively, the OH group is attached to the primary carbon, it becomes the primary alcohol. The OH group is attached to the secondary carbon, so that means secondary alcohol is this. And the tertiary carbon is attached to OH, that means it is tertiary alcohol. About the nomenclature of the alcohol, we have already done the nomenclature in the unit 1. So now we are moving to the alcohol preparation. Today we will do only 3 preparations, basic preparation of alcohol. The first one is the hydrolysis of haloalkanes or alkyl halides. Haloalkanes, they can be converted to the corresponding alcohols using aqueous sodium hydroxide, potassium hydroxide or calcium hydroxide. You might remember that this is the reaction which we have already done, that is substitution nucleophilic reaction. So with this method, primary and secondary alcohols are formed from a primary and secondary alkyl halide. And as this is the SN1 reaction, but the very important point is that the reaction can only be held when reactant that do not go under the elimination 2 reaction easily. Then only this hydrolysis of haloalkane can take place. Now next is reduction of the carbonyl compound. The carbonyl compound which contain the carbonyl group such as aldehyde, ketone, carboxylic acid and ester, they can be reduced to the alcohol. You see the example. This is the ketone group, carbonyl group, and this is the aldehyde group. It converted into the alcohol. Now aldehyde gives primary alcohols while ketone yield secondary alcohol, either by the catalytic dehydrogenation or by use of some chemical reducing agent like lithium aluminum hydride. Remember that the carboxylic acid and ester also give primary alcohol on reduction with hydrides reagent, just like lithium aluminum hydride or sodium borohydride. And about this sodium borohydride, that this sodium borohydride does not reduce the carbon-carbon double bond. In case when there is in the conjugation with this carbonyl group, if there is a double bond, so this sodium borohydride do not reduce that carbon-carbon double bond, and that's why this is very useful in the reduction of the unsaturated carbonyl compounds to the unsaturated alcohols. Now the next is from hydration of alkenes. So hydration, that is the addition of the hydrogen ion or OH ion across the carbon-carbon double bond, and that gives the alcohol. So this is an electrophilic addition of the water to the alkene. An alcohol can be prepared by adding water to the alkene in presence of a strong acid such as sulfuric acid. And because this reaction follows the Markovnikov rule, the product of the reaction is often a highly substituted secondary or tertiary alcohol. So this is the example in which the hydration of alkene takes place in presence of a strong acid H2SO4, and that follow the Markovnikov rule in which the secondary or tertiary alcohols form.